Okay, so what we're looking at here is a host that I've downloaded the entire, it's a Linux OpenSUSE system. I've downloaded the CoprHD source. I've done the make, all the RPM, followed all the instructions that I put on the wiki for that, verified it came up and ran, and then I've actually run the sanity test against it, which is why you see that it's populated. Covered a copy of the all-in-one simulator that I've deployed and got some storage systems of various kinds populated. Looking at a quick and easy way to get some data into a CoprHD instance that you've deployed, having it run. Well, basically there's, so a lot of what I did when I was, in some cases it was creating new content, and in other cases it was sort of giving you a cheat sheet of how to get into other content where it was like, I don't know where to start. So
Bill just sent me a text. Thanks, Bill. Oh God, that was scary.
I don't know where to put this. Doesn't really have. All right. Hopefully, folks on the phone can hear a little bit better now. So, part of the job was to create some new content where it was missing, and part of it was to sort of make some of the content that was there in great detail a little more accessible. So, with regard to running Sanity, I created basically a sort of simple steps to run Sanity that gives you some references to both the sanity test detail and the simulator detail, but sort of gives you a cheat sheet of this is the absolute minimum amount of things that you need to do to get Sanity to run. And so it's like, okay, deploy your Sanity VM and then modify these files and run this, and it'll probably get you going. Now, if something goes wrong, you may need to read the detail to know a little bit more, but at least it gives you a short path to doing it. And so that was the case with a lot of the stuff that I put on here was, all right, what do the whole volume of stuff on the wiki, even though, as has been indicated, there's stuff that's not there yet, there's quite a bit there as well, and it's hard to know where to start sometimes.
Yeah, I just reorganized that page, the one about the simulators.
Okay.
And I'm in the process of making some videos. So hopefully between this and next, have separate videos for each kind and another one for the all-in-one.
Okay. So we can get to Sanity and running it later if we want to, but it sounds like from the overall sense of the room was that sort of IDE setup was a priority. So let's take a look at that. So for the most part, developing purely in your IDE is not going to be an option. I say for the most part. For the most part, you're going to need somewhere that you have done a full RPM build and install of CoprHD, right? Because there are parts of the build that only run as part of the RPM packaging. And so your first step for getting a fully functioning CoprHD is sort of building the RPM. But then what you can do with your IDE, if it's running on Linux, you could run your development system and your CoprHD system could be exactly the same one, right? You can have your IDE running there, you can build the code, you can do what you want all on one computer. Otherwise, you can run Windows or Mac, you can run your preferred IDE there, and you can edit the code, and then there are some tools to selectively replace individual jars or whole sets of jars in your running CoprHD environment and test the code. And so we'll talk through some of that. Like say if you have a Mac, Windows is far enough from, there's enough stuff in CoprHD that sort of assumes things about Linux file system paths that trying to actually make the whole thing run on Windows is very difficult. Mac, on the other hand, is close enough that there was some work done to where literally they had most of the services running on Mac, and I can point you at least in the direction of how they did that, if that's useful to you.
It did work on Windows before they did it, except that they had only Mac, so when they put it in and grade or so on, they only kept Mac things because they
So, in theory, it could be made to work again, perhaps.
I mean, so keep in mind, I mean, steps of some interaction with the operating system, configuring things like, network, configuration files that we do using, shell and Python, like Once all configuration files are in place, you just replace the jar file. No Java. Moreover, for all services, and once you have the configuration files correctly configured. So there's one more thing that I probably didn't mention. So officially we're focused on 3 and 5 node configuration. So that's not very practical for every developer. So there are 2 different single node configurations. One called 1+0, which is exactly like this cluster with just one node. And what this means is that in the cluster, services no IP addresses of other nodes. On a single node, even though it's a single node, you get one service calls to other service. The portal service calls to it all goes by the zip with some public useful IP address. There's another configuration called standalone, which is a single node. So we deliberately create a set of configuration files. So we don't need to expand because they all go through localhost. You can even have this instantiated with DHCP dynamic address, but it doesn't matter. All services are wired to localhost. When you develop on some platform, you use these localhost configuration files. Then it really doesn't matter what these things are. All services call to each other, to localhost. You don't need to. It doesn't depend on your, public IP address and so on. So you will notice that you will use this, standalone configuration. I think many instructions, but if you try to develop things and have some Java services that don't involve this service, other things that have, some OS interfaces, there's no reason why this thing could not work with Windows and Mac correctly. So you guys were focused on, how we use API service, portal service, etc. I know that they were able to do entire development on Mac and just barely test things later when they moved it to
Makes sense.
Things like systems, etc. I mean, they have serious problems. They actually rely on invoking some shell script program operations, distributed escalation, and so on.
Okay. So, as we've said, the first thing you're going to want to do is on whatever your Linux system is that you're going to develop on, check out the code there, build the RPM, install it, get it going. If you're not going to be developing on the same system as that for your IDE, then you're going to want to clone the code on the system where you're going to be doing your developing. Obviously, you want the same branch, basically the same code, otherwise you're going to end up in pain. And then you're going to want to, create your Eclipse workspace or your whatever the equivalent is in IDEA. So I'm going to create a new workspace here just so I can sort of go through this demo. What you're not going to want to do is go into Eclipse and then just point it at the directory where you checked out the code and say import everything. You'll end up with a mess. So the build has the capability to generate project files for Eclipse and the ability to generate project files for IntelliJ. You will want to use that capability. Otherwise, it just will not work out very well. And so you'll run your Gradle WOSS Eclipse, Gradle WOSS IDEA, and it'll produce all the project files that you really want. And so I have done that over on my Bash deal, and so then you go and tell it, instead of telling it to create a project that didn't exist, you go and tell it, I want to import existing projects, even though you may not ever have worked on one, you generated them, and so you have them now. And so you go and basically point it at wherever it is that you created your source code, which in my case is down under controller. And so it's going to go in and it's going to find all these project files that were generated. And so these are you probably saw these in Tom's workspace earlier when he was going. It's a lot, right? So you have a whole bunch of projects and you really want all of them. So I'm going to pull these all into my Eclipse environment. Make it a little bit bigger here as well so maybe people can actually see it. So this is sort of your first step on getting going. It's going to want to build. There are some tricks to this, and so we'll see. It's in the process of building. This wiki page, which I've put together, we'll talk through some of them. One thing that we've done is we've sort of, the Viper controller code was a bit of a mess in terms of code style. We had some standards, but we hadn't enforced them very well. We have sort of created formatting templates for the various editors to sort of comply with the style that we've set, and we largely reformatted all the CoprHD source code a month or so ago to sort of comply with them. And so we have Sonar running, enforcing both some bug checking as well as some style stuff, and so to avoid getting snared in code formatting violations, we recommend that you basically import the code style templates into your editor when you're working on CoprHD so that you'll comply. Let's see if we're to that point yet. Okay, so one other thing that we'll probably see, so the actual build of CoprHD is handled by Gradle, and right now there's some cross-project referential stuff in the Gradle build that's not ideal, and so when it comes into Eclipse, it starts telling you this about there's a cycle that's been detected in the build path, and it makes it very unhappy. I've documented on the wiki how to go in and fix this. Basically, you have to go into your Java build and tell it that for build path compiler building circular dependencies, make it a warning, and it'll undo it. Ultimately, we want to fix this, but we haven't gotten around to it yet. So this workaround will get you where you can get to a clean build. I presume there's something similar in IntelliJ. Also show you basically how to import. So this particular one that I just talked about is number 6 on this list. Information on importing these code style templates I can show you as well. So if we go look at we basically have the formatter templates that are here on the wiki. They're available as XML files that you can download, and so you can go into your Java and code style and cleanup, and you can basically import the formatter for cleanup. You can go into your formatter and import that as well. I downloaded these earlier so they're convenient. Both of those, you'll comply with the code style without having to work at it too much. The other thing you'll note is that after doing that change with regard to the circular dependencies, all these projects imported and I have no actual errors. And so Eclipse actually has a full build of all of the code, and it's going to be able to do your code refactoring and all the rest of those kind of things correctly. If you have errors in the code and it doesn't build right, you're going to lose some of your capabilities in terms of refactor and code sense and some of the rest. So it's kind of important to get to a clean build state. Key things, we do have Sonar running, and so one of the things that we're working to get done is basically pull requests, which we'll talk about a little bit later. When you go to submit code to CoprHD, there are a set of sort of requirements of what you need to have done as far as testing, as far as complying with code style, and the other thing that we're enforcing across the project is we don't want regressions in terms of bugs found by find bugs or PMD or the various things that are running as part of Sonar. And so when the pull request is pulled up and the committers are looking at it, code, they're going to see very clearly that there were 0 critical bugs in the code base before your submission, and with it there are 5. You can pretty much be sure that your code request is going to be sent back and say, you know, resolve these issues before we'll even consider merging this into the code base, because we had a very large number of technical debt, or amount of technical debt in the backlog when we first released the code. We've gone through and we've filled almost all of the blocker and critical level things. I'm not sure, there might be a couple floating around there now. We're going to try to keep those at 0, and then we're trying to drive down the majors as well. And so that's going to be a focus both internally within the EMC engineers, but as people start coming online as contributors, it's going to be key that if you want to fix some, that's great, but don't make it worse. So, and again, we have detailed information on the wiki here about how to, oops, wrong one. Go in here and go down as a developer. How can I see what violations I have? And so basically you can install the SonarQube plugin and then point at the Sonar server that we have running, which I'll go take a quick look at. CoprHD controller. Yeah, so at the moment we've got 2 and 27, so we've got a little bit of work we need to do to get those back to 0. But we're trying to get those down to 0 and then start driving down major. A lot of the major is right now Java doc related, and so it's not as bad as it looks. But yeah, we're working on getting all of these down towards 0.
So you know attention to that number.
That's
608.
Yeah, apparently. So if you follow all of these steps, then what you have is all the code, and so you can go in and look. So Tom was in the controller service. You'll have a project called controller service, and you can find all the code for that there. You'll find the API service. You'll be able to navigate the code with a fair degree of effectiveness, and it's all in your environment. So that's pretty nice. But how does that help me if I'm not on the same machine as I'm running CoprHD, right? So what you can do, and what the Gradle build will let you do, if I can figure out a contrast scheme that'll let you see what I type. I've got where you can actually read my text, but you can't read what I type, and I don't see how to readily fix that, since I'm not among the contrast settings that I have access to. Text, and it's not screen background.
I mean, pop-up text, take up the black and background to
I think I didn't seem to be pop-up text when I looked at it, because the pop-up text seems to be showing as being purple right now, which doesn't seem to be what I'm having on my screen. So let me try. I'll go to black. I'll go to black and white, and we'll see what it does. But I'm not convinced that's going to help. Almost unreadable. Let me. Something in the deep bash guts here that I lost my contrast settings as well. Good job. All right. Really need to do this on a projector so that I can actually. Helping.
what happens to the highlight?
Let me try a Windows. Let me try a Windows command prompt. I don't usually use that, but maybe it will behave better.
How about just Notepad?
I could do that too, just to show the commands. All right, we'll go that route. All right. So what you can do, as we've indicated before, we've got this CoprHD running over here. We have a environment that we logged into. We're able to navigate into it and see our physical assets. We can do what we want, but if we want to make a code change to it, one option is I can go log in over there and I can run VI, or I can run whatever my favorite Linux editor is if I don't have Eclipse. And a lot of our dev kits, the way we do Viper is we have headless Linux systems that are serving as dev kits, and then people have a development environment somewhere that has a GUI, but they're not necessarily the same. So if you don't want to do that, and you don't want to be constantly copying code back and forth, the build system has something called the DevKit plugin. And again, DevKit is a little bit of a strange term for someone outside of Viper, because DevKit, a lot of times you think of an SDK or whatever. Well, DevKit, and when you hear someone that's worked on Viper talking about it, is literally a Linux system that's been set up to build and run CoprHD. And so when I say I want to deploy code to my DevKit, I mean I want to deploy code to the environment where I'm running and have the capability to build the full CoprHD setup. So how to deploy a code change to your DevKit. Assuming you've got your IDE set up and running, the Gradle build has a set of tasks that you can run that will take a subset of the Viper code and replace what's running on your DevKit with it. It will stop the services that are running on the dev kit. It will copy over one or more jars and XML configuration files. It will restart the services for you. And so if you make a set of changes in your IDE, you think you have it where you want it, and you're ready to test it, then basically you can run something like Gradle WOSS API service dev kit deploy. In that case, it's going to replace the storage-os-API service.jar on your dev kit with one built from your local environment. There's a whole set of tasks. You can do multiple individual projects by name, or you can actually do things like deploy all, and it's going to replace basically every jar on your dev kit with the ones from your other environment. There are some tasks to do individual things like start, stop, restart services, clear the logs directory, clear the database directories. So there are a number of different utilities that you can use here to replace pieces of your code on Viper. So if basically I go here into the Ops API service and let me pick something. Virtual array. All right, so what you'll find is in most cases in the API service, the things all end in service, and so this is basically the REST endpoint for listing virtual arrays that are in Viper. You'll kind of learn the pattern eventually. So if I want to, I can make a change here that basically just puts in an extra log statement or something like that. So I think we really need more logging in this, and so I'm going to log. That's our info. Okay, so that's great. I know it built because Eclipse just built it, so it's perfectly valid code, but if I want to run it, what can I do? As indicated by the smart person here, I'm going to bring up Notepad, but actually it's going to be the exact same command that I just showed you. Because I'm in the API service, note what project the file I'm in changed, I know that that's the API service project, and so if we go look at what I showed you here, my example was actually from the API service. So if you're familiar with Gradle, then you'll know that if you're trying to run a command on a specific project, then you put the project as a prefix. So this tells it, hey, go run a task against API service, and the particular task I want to run is dev git deploy. And so I'm going to take this command and I'm going to copy it.
Okay, well, how does it know where your dev kit is?
If we go a little bit farther down in here, we talk about dev kit plugin configuration. And so basically in your home directory for your user, there's a .gradle directory. Assuming you run any Gradle commands at all, it creates that for you. And inside that, you can create a Gradle.properties if you don't already have it. Three values here are relevant. DevKit, which is the host name of your DevKit. It could be an actual host. It could be an IP address. If your development environment is the same as your CoprHD environment, you can put localhost, and then it would just copy jars over to your local directory. It'll work no matter what. By default, root and change when you're there, but if you've changed your password to your device, it's literally going to SSH into whatever host you tell it using these credentials. So give it the right credentials for SSH. If you put this information in here, then it'll know where to send this information. This org Gradle daemon thing has nothing to do with DevGit plugin, but it's a useful thing to do. It'll make your build run faster. And then we've got since we already kind of on this topic, again, we have the full task list of things that you can do with this. So notice the first one in the list is what I'm doing, a project-specific dev-kit deploy. I could do a project-specific dev-kit deploy deps, which would calculate the dependency tree within Gradle and deploy all the dependent jars as well. So if you're doing a change that has changed some APIs that might affect things outside of the particular project where you are, you may need to do that. You could list individually the ones you want, or you can do deploy all if you just want to take complete replacement of jars. But I want to make the point again, DevKit deploy all is not the same as completely rebuilding the RPM on the other side. In other words, deploy all is going to replace jars and it's going to replace XML configuration files, but it's not going to rebuild the RPM and redeploy it. Things that are outside of the Java realm that are part of the RPM are not replaced by it. So just be aware of the limitations of deploy all. It's not the same as reinstalling the full RPM. Okay, so I'm going to copy this, and what we'll see happen if I go and paste this over into my other environment is basically, again, you may not see it because I won't even bother to copy it. It's too much of a pain. Figure out how to get this to actually display, but okay, hey, it's working. All right. Okay. So it's going to spin through, it's going to figure out what you've changed since the last time you ran a Gradle command. It's going to recreate the jars that it needs to create, if any, and then it's going to start telling you what it's doing over on your dev kit. And as soon as it starts actually doing the deployment, then we'll see that CoprHD is down and won't run until it comes back. Okay, so it's figured out everything it needs to know. It's stopping, it's literally running etsy StorageOS stop over on the remote DevKit location at the moment to bring down CoprHD. You can see it copying over the XML files that we were talking about. These are largely Spring configuration files that set up some of the beans. Now it's going to rebuild the jar that it needs to actually replace the API service jar over on the remote system. And then as soon as it finishes that, it's going to restart the CoprHD services over on the other side. So while I can't claim this is exactly instant, if you've run this recently, it gets faster because it has less dependencies to recalculate. And it will get you at least a way to cleanly move individual jars over or whole sets of jars over to your other side and test. Now, what you can take a look at, and again, this is something, we'll let this go ahead and run, and in a minute it will finish, and well, it's almost there, so we'll let it go ahead and do copy and restart. And while it's restarting, I'll show you something else. Yes, it uses the JSDH Java library for SSH to copy the things over, and then it's doing the start services on the other end. So basically, if we go look over on the other side, basically the XML files and jar file related with the API service will now have newer creation dates, and the services will start running. At the moment, if I try to refresh my physical assets view, then it's going to probably tell me unavailable because my dev kit is still in the process of absorbing those changes that we just made. So what other options do you have? Well, one thing that is created in addition to all of these individual projects, there is a project called Runtime. Runtime is a little problematic, but basically what it is the attempt to add some run configurations for CoprHD into your IDE. So there's one called Viper and one called Viper Boot, and when they work, between the two of them, they bring up the entire Viper system inside your IDE. I have seen this work if you're running your IDE on Linux. I've seen it run if you're running your IDE on a Mac. I have not ever seen it run if you're running your IDE on Windows. Again, a lot has made the point there's probably no technical reason it couldn't work, but no one has done the work to get all the pathing and things right for this. And so for those on Macs or have their Eclipse directly on Linux and want to try to run everything within the browser, these would be something you could try. You might have to tweak them to get them to work. Likewise, another thing that's done pretty frequently is people deploy a dev kit, but if they're working on the UI, you can basically bring up the portal service only inside a browser, and that one has worked Windows, Mac, anywhere else. And so these are not super well maintained. I can't speak to exactly what their state is right now, but all of this can be made to work. And so we can, if you try them and they don't work, then we can try to work through getting them going. Portal only definitely is used routinely by Viper developers These two, I don't know for sure who's using right now, so they may be in good shape, they may not.
Okay. I used to use those and I love them. The only trick is if you use them, make sure all your logs and your configuration files go in separate directory structures. And look for them as something that begins with runtime, blah, blah, blah.
Oh, there's a different directory where the logs end up?
Yeah,
Okay.
in your database.
So I think what we've seen is we have some people like Tom who deploy a Linux OpenSUSE box, or I guess or regular SLS box with a UI on it and run Eclipse on Linux, and they do sort of everything on one. We have a lot of folks that run Windows as their primary development environment and use these dev-kit deploy type stuff to synchronize code back and forth between them. We had a large and vital community of Mac developers who were doing a lot of this runtime stuff, though a lot of them moved off onto another project, and so that's why I'm not sure how well maintained.
Great. At some point you should discuss it, because it all works great if you run dev-kit standalone instance.
Mm-hmm.
There are people who have to test things on the cluster.
Mm-hmm.
It doesn't work very well on the cluster.
The documentation for the DevKit plugin claims you can put a list of IP addresses on that DevKit IP address. So in theory, you could deploy to all of them.
In principle, at some point there was a discussion and an idea that instead of having all the plugins in Gradle,
Mm-hmm.
you could just create a script that is clever in populating actual runtime with what you have in your workspace. In the workspace that is intelligently.
I think that's what Bill's Ant scripts did to some degree. They were more, I mean, the Gradle scripts are literally, I mean, your IDE has wherever it builds its Java class files, right? But when you run the Gradle script, it's doing the build itself to make sure it's happy with it and it's deploying it. I think there was a different approach where it was literally capturing the compiled code from your IDE and deploying that.
So the issue was also not only how we do it for some kind of development, but how we pass things in production. We could really have a tool for doing it, right?
Theoretically.
Actually do both.
Yes.
One thing I would like to point out is the debug script.
Yeah, I'm gonna do the remote debugger attach thing for him. Yep. Okay. So I kind of went through that at a pretty rapid pace. Questions, things I didn't cover, too fast, too slow? What can I tell you more about this part? Yeah. Okay, so if you've done this as a prerequisite, you have all the code in here, then you're in good shape to potentially do debugging, right? So let's go take a look again at the wiki. Let's see if my CoprHD successfully came back.
When you deploy DevKit, is the prefix always going to match the name of one of those packages you see in the IDE?
Well, maybe. Yes, if you're doing a project-specific one, right? So there are a couple of tasks. You can run DevKit deploy or DevKit deploy tasks, and those are run against a specific project. And yes, those project names will match project names from Eclipse. These are global commands, so you don't put a project prefix on deploy all or stop services or start services because they're not associated with a particular project. When I'm putting a project name in front of DevKit deploy, I'm literally telling it I want you to deploy the jar associated with that project as opposed to some other project or all of them. So you've got Eclipse, you've got your code building, you know how to deploy a code change. It's not working the way you thought it should. So let's take a quick look at how we might go at debugging. So the thing Tom was just mentioning is that there's if you haven't looked at what the structure of what happens when you build the RPM, you probably should. But basically, almost everything that's important either goes into op storage OS or goes into /etc. There's, I guess, maybe a few other things, but there's op storage OS conf, which has tons of XML configuration files, which are good. There's op storage OS logs, which has the logs for almost everything. But then you also have this bin directory, which has a bunch of scripts that are used to start services. Generally speaking, if we go look at one of these, it's basically going to be a bash script that sets up a bunch of environment variables and then ultimately calls Java and tells it what class to run for the service. So by default, Service script that runs is the one that's the exact name of the service. So the API service gets started by a script called API service, and DB service by DB service. All that's pretty self-explanatory, but there's two other scripts for each service in here. One of them has the suffix -debug, which basically does the same thing as the normal one, except it starts the Java process up listening on a specific port for attachment by a remote debugger. The coverage one either does CoprHD or one of the coverage tools. Largely our testing team uses this option to sort of get some code coverage numbers. CoprHD, yeah. Okay. Yeah, I'll defer on that one. So, when you look at what the storage OS system, when it comes up, does, what it's really looking for when it tries to figure out the name of the service script to run is it's looking at the contents of this file, sysconfig storage OS. And it's got this variable called storage OS variant, which by default is empty. So when it tries to figure out the service start script, it looks for something that has the service name plus the storage OS variant and runs it. So by default, since it's empty, it runs that one. But if you edit this file and put -debug in it, then any service you restart after that period is going to run the debug variant instead. And so one option for starting a service in debug is to modify that file, and then, as Olaf has said, you could just do kill -9 on the service and it would restart. Or you can actually use the system control and officially restart it. Whatever approach makes you happier. We'll bring the service up in debug. Another option that a lot of people do, which either they don't know how this works or they just think it's simpler, is you can basically save your original start script, copy the debug version over the top of it, and then restart your service. Your advantage there is that if you forget later and restart all your services, you don't end up with the entire system coming up in debug then. You still just have your one service in debug. So,
okay, so my guess is that approach 1 at the moment is broken.
Oh yeah?
I think so.
I used it. I tested it before I actually did this. I mean, it's broken in what way?
Things work consistently.
I think I tested it both ways. It seemed to work. I'm not sure there's no side effects, but it did at least bring it up in debug.
Okay.
All right. So the steps, if you want to do this, pick your approach of choice, and then you're going to want to launch the debugger in your environment. So I'm going to go ahead and do one of them, although let's see if I can.
With the third one, if you reboot it will work, but I'm not sure that it will work succeedingly in the
It did. All right, tested that. All right, so let's see if I can get this where you can actually see my PuTTY session, which at the moment you cannot. Modifying, I'm doing the default foreground will go black. Default background will go white. Okay. So what am I trying to demonstrate? Oh, yes. So I'm going to go to op storage OS spin. So let's see if I was lying to you. API service. All right. So we in fact have 3 scripts. I'm going to copy.
The forward is inside.
Okay. Oh, now you're going to get me into. There we go. All right. So it gets ugly, but basically, as I said, there's some variables that are defined. Where's your Java? Where's your path? There's a bazillion jar files being put into the class path, and then ultimately you've got Java being started and normal startup script, and so it doesn't have anything too special in it. If we go look at the debug one, it'll be slightly.
Okay, so there's one thing that the work mentioned. So there are functions that calculate each size of a particular parameters are defined in our Gradle loop file specific for different purposes. Please memory on your machine. services proportionally get somewhat different size of report size, kind of linear scaling. Some services will grow fast, and you can see there are some.
These scripts are all generated by the Gradle build as well.
You will see the results when you look at different scripts. These parameters here are different. There's the time to calculate how much memory. Different services in the Gradle type, these parameters are fine. Fine whether your memory is mostly, flat with the scale of memory, or whether you want to be practically more memory to use in service out of what you get over the minimum system.
So what I'm going to do is I'm going to back up my API service script. Just in case I might want to go back to it, I'm going to copy my API service debug script over the API service, and then we'll go the OLAP approach here, and we'll find the API service. I'll kill -9 on. All right. Okay, so this will take a little bit. I think in the wiki that I created about sort of watching everything start up, I gave you kind of a cheat sheet in terms of how to know when. What's that? So one thing, remember we talked about the service beacon, so you can see when the service beacon comes up for a service is usually the last thing, tells you it's pretty much ready. You can also see that it's actually established its SSL connection endpoint, so it's up and running. So the question here is, all right, so it's running, it's allegedly in debug, assuming I did everything right, but where do I want to connect? If we look at the bottom here, all of these debug scripts ultimately have an address on them where different services are on different ports, and so the API service is 8004, every other service in Viper would have a different port, and so if you want to know what remote port you're supposed to connect to, you can come look at the script, and this will tell you.
And it's further defined also in Gradle.
Right, in the Gradle build file. So what I'm going to do, I'm going to take my Eclipse debugger, bug configurations, and Java application, create a new one, write service context, all right, so 8000, anyone remember what it was? There we go. All right, and then you have to fill in the appropriate host. Again, Olaf had mentioned, I think, during his original demonstration, but if your firewall is up when you're trying to do this, you will be very frustrated, so you probably want to shut down the firewall on your remote system if you have it running by default. And so I can tell it I want to launch the debugger. I'm going to put a breakpoint on this new line that I created. And so what we're going to do now is out of browser and our reload. There we go.
Sometimes I'm stuck in the browser window.
Oh, yeah, so we're back to life. All right, so this is the UI, and I think Olaf had mentioned that 4443 is the default port for the UI, but it's not for the API. So we're going to put an explicit port on here. That's true. Yep. Virtual assets, block virtual arrays. Yep. Actually, you're just cheating for me, but yes, that'll basically should cause it to hit a breakpoint, which it did.
That's something I think has been mentioned before, but just wanted to remind everyone. Anything you can do through the GUI is being done through the API.
Correct.
So never. But there may someday be more API than GUI, but if you see it on the GUI, that means there's a public API out there that you can integrate.
Right. And so I basically, through the UI, I had told it to list the virtual arrays because I had gone into the virtual array service and set a breakpoint on the get for the sort of wide open deal. As soon as I did that, my remote debugger kicked and my breakpoint hit. And so basically, I can step through as much as I want and figure out, oh yeah, there's my log message. If I go look now in the log file, then presumably I can find that, assuming it's finished yet. And then when you're done, obviously you can release it and let it go. So then the UI will presumably be showing my two virtual arrays. And if I go look here, let's see. Yes, we can.
There are two tools debugging. One is debugger. You get a lot of value, but you need to be careful how you use it. The other is instrument. Again, you have another type of problem that is messages that you're on different hosts in different boxes.
Okay, so now I'm back in the debugger, and why is that? Because I went to the actual REST endpoint. Notice I'm now on 4443. I type vdc/varrays, which is the REST API associated with that. Don't pay attention to the payload. That was from the prior request. So I'm back here. If I release the debugger and let it run, and then flip back to my browser, I'll have the list of varrays represented as XML coming out of the REST interface. And so if I refresh this, then I'm back in the debugger again. And so you can set as many breakpoints as you want. You can get to them either by making REST calls directly using your browser or using the REST client of your choice, or you can, if you know how to get to the right spot using the UI, then you can do that as well. So questions about this?
And for the most part, too, when you're debugging, the hot swap works really good. So if you are making simple code changes while you're in the debugger, it does a really good job of resetting the frame back to the beginning of the method after you make the code change, and you can just test it without having to do the, the dev kit deploy steps.
Thanks, Bill.
You mean like changing the code right here?
Yeah. Changing the code while you're attached to the debugger. And
you don't have to upload anything. Just keep going. Nice.
Yep. So between these two, you know how to get non-debug code deployed remotely, and you also know how to attach and step through what's going on over on the remote side. So I hope that both of those will put you in good shape. What else do I want to show you from? Okay.
Also, if you use IntelliJ, you will notice that Eclipse debugger is kind of a little bit more powerful than IntelliJ. There's some aspects of IntelliJ that are better than Eclipse.
Okay. So those are your two pieces of setting up your debugger, setting up your environment. I don't know if there's anything too revolutionary in these other ones. Do we want to go into Sanity, or do we want to talk a little bit about how pull requests work, or what are people in?
We have time for both.
And for the whole JIRA process from beginning to end, there's that little video.
Yeah, we can take a quick look at that, I guess. Let's see, I actually have, so let's take a quick look. I've got where you can actually see. Problem. All right, so again, Sanity, there's a large page about simulating hardware. Well, first of all, Sanity is basically a set of Python scripts that act as a sort of set of integration tests, I guess you would call them, and for purposes of development can act as a way to verify, number one, have you caused regressions? If something worked before your change in Sanity and didn't after, then you probably broke it. And then if you've implemented some new feature, then if you add that to the Sanity suite, then running Sanity will likewise have regression for your feature function when they go to test their changes. So there's a number of different ways that people test code in CoprHD, but one of them is the Sanity scripts. The Sanity scripts involve interaction with outside hardware. That's what Viper largely does, right? To test Viper is to manipulate storage systems, but maybe you don't have a VMAX in your basement. So what we have done is there are a number of simulators that we have for certain types of storage hardware, as well as a tiny LDAP server that you can use for running some of the authentication tests. And so they have been bundled together in what's called the all-in-one simulator, which is basically a VM that has an LDAP server, a simulated VMAX, and I'm not sure, you can read the page to see exactly what all kinds of simulators are in there. But basically one VM that you can deploy that can get you enough to run what's called Sanity Quick, which is sort of a basic small set of tests that will create some users, do some role assignments, and do some basic provisioning operations against Viper. It won't exercise every possible Vplex configuration case, although I think they've been doing some work on getting more of that working with simulators as well. But the sort of the baseline of what you need to be able to run is if you can't run Sanity Quick after your change, then you probably broke something. So your first step there is you can either, if you have the capability to deploy a VM, you can download the OBS file, and I think there's capability to either deploy it under vSphere or VMware Workstation. Either option suits you. You can deploy one VM and it has all the simulators on it. If you don't want to run a VM, there are instructions on the page for downloading each of the individual simulators, and you can install it directly on your Linux box of your choice and run it that way. So pick whichever way makes the most sense to you. I documented using the all-in-one because it was the easiest. Likewise, on your dev kit, let's take a quick look at a tools test directory here. It's relocated recently, so I can remember it. So the entry point to Sanity is Sanity. Again, it's a bash script, and then there's a whole ton of various little bits and pieces of Python code that's in here. And then underneath here, there's also a conf directory. By default, there's what's called sanity.conf. This is actually checked into the source control. My recommendation is if, before you start messing with it, copy it over into a local file so that you don't. This is a checked-in file. I'd rather you not submit a pull request that puts your own local values into the default sanity.conf. So, you know, whatever it takes to keep you reminded. But my suggestion was to copy it and then change it. But that's up to you. There's really only, assuming you've done this all in one thing, there's really only two things you've got to set, maybe only one, in order to make Sanity work. You've got to set the right password for your CoprHD VM or host, whatever it is. So it's going to try to log in and do some things as root in Viper, and so it's going to be change me unless you already logged into your CoprHD and changed it, but if you have, you'll have to tell it what you changed the password to. And you're also going to have to tell it what IP address is a simulator running on, so it will know how to add that to CoprHD. so the question that I'm not 100% sure on is whether I reset my simulator after the last time I ran it. So let me take a quick look. You can tell it like a git ignore, but this is actually a file that's actually is a git file. We just don't want people in general to change it by accident. I don't think you can have git ignore. I don't think it'll work right on a file that actually is under control.
You want it in the repo, you just don't want to change it.
Yeah, but you know.
Yeah, I don't think that'll work, but I agree it would be nice to have a solution for it. So, again, on the wiki, this is documented, but basically when you want to run Sanity, you're going to tell it you want to run Sanity, you're going to point it to the configuration file you want it to use, you're going to tell it what IP address that you want to run Sanity against, and you're going to tell it what piece of Sanity you want to run, which Quick is the only option right now, I think, for that we have working successfully against the simulator that are deployed outside the EMC environment at the moment. Isn't there some magic setup they need to do to set up their simulators for that if they want that to work? Yeah, I know that we're working on that. So basically, previously we didn't have hardly any Sanity that would work outside of EMC's lab environment, but we're trying to get more and more of that available so that people will be able to test. So that's actually, yeah, actually you do right now with the state of Sanity, and I actually haven't done that yet. So let's take care of that at the moment. So I ought to do a couple of things, I guess. One is I ought to probably take the thing out of debug. So where do I spend? Not clear data. API service clear data. That's clear data. Okay. So I think Olaf mentioned, or Tom did, I think Olaf, that basically most of CoprHD, well, not so much with CoprHD, but very much with Viper, is non-persistent copy-on-write file systems. But the /data directory is the area where basically all of the persistent storage lives. And so what this thing is doing is basically wiping out the persistent Zookeeper and Cassandra files and then restarting services. And so right now the Sanity scripts are not reentrant, and so in between runs you have to sort of clear the database, or else it basically tries to create some objects that already exist and will error out for not good reasons.
Thinking about this, that's one thing that you need to do much. You have some and you want to wipe out the database. You do it node by node. And I shut down the database, I wipe the database and restart the node. That's what you don't do. Because at any point of time, the database is alive. You need to shut down all of them, delete the databases, start all of them again. Right, the replication that happens in this window where there's a lot of data, and a lot of data may get to replicate the VM. What's that command that you run that before this?
It's one of the devkit commands documented on the wiki. I mean, you can do it manually, but basically it is devkit clear data.
Oh, right. Okay.
So it's on the devkit commands wiki that's linked from the developing on CoprHD. But you can clear logs, you can clear data, you can deploy code.
And this works with one instance, or does this work even if you have the whole
a multi-node cluster, I think it would probably be subject to the problem. I mean, I think it will go sequentially through them, but you could have a timing issue probably.
Right. Okay.
As Tom said, generally speaking, most of us do the majority of our development on single nodes, although there are weaknesses to that, right? There can be some multi-node locking concurrency issues you won't find if you spend too much time.
Sometimes, right, that's the thing. And trigger, particular instance of particular certain. So I don't know if to all 5 nodes that I have. Up to this one where I know that the code will be executed, but then will be executed there, right?
Yeah.
I mean, you do it again, remote debugging. You don't try to connect your debugger to all 5 key instances of APIs and run it.
So the API service is coming back up. As soon as it's ready to listen for connections, then we can run Sanity against it.
And the way to look at the plugins that are here, I mean, this was not something that we developed as an organized effort. We need to have this plugin. This was things contributed by developers who wanted to have automation, and they put a little bit more effort to make this thing useful for everybody. So there's something else that is useful. You want to improve this plugin. It's free. I mean, it's all, going effort, how to have some people use this way, some people use another way, and so on. So there's probably more than one way of. This one clearly has, some thought behind it. And then,
Almost there. So this is going to be, as I run this, it's going to be kind of anticlimax, because basically what you're going to see happen is you're going to see this Python script run. It's going to run just a whole bunch of commands against CoprHD. It's going to have it discover aspects of the simulator. It's going to actually run some provisioning, some simulated provisioning operations. I mean, as far as CoprHD is concerned, it's real, but it's running it against the simulator. And it's ultimately going to report success or failure. It's not super exciting, but it is, you may know about one particular area that you've changed, but you may not know that much about other areas, so it's a way to sort of give you a readily runnable test that can exercise quite a bit of functionality without you having to be an expert on all the places you might have accidentally broken something in the code.
Yeah, so in other words, if you
write a good sanity test for your area.
Run a sanity test, make it part of the sanity test. And you write a good test, and if you have, some confidence that will not be breaking all the time.
So I've invoked sanity, I've told it where my configuration file is, and I've told it to run against a nonsense host. So that's not going to work out very well. Dangers of cut and paste. OGLW75.
And so far, from our experience, things that don't have sanity tests
Get broken a lot.
get broken a lot. After doing it, it happens sometimes?
You would, yes. I mean, once provisioning gets going, yeah, you can see the I mean, it's basically it's calling the REST API, and so the UI doesn't care where they originated from. So yeah, first it's configuring some settings, it's configuring some users, it's doing some role assignments, but once it discovers some storage systems and things, then that kind of stuff.
This is probably an area where we're going to want to expand on community-wide, especially if we start getting other companies like so that we do more like what Tinder does, where every company kind of has their own build system and it runs against their hardware. We'll have to come up with something like that can, it won't be exactly this, but we can map to.
Yeah. So you can watch it scroll by. Again, it's throwing me in I haven't done, because I wiped the database and Zookeeper, it's throwing me into sort of the initial setup mode for the product, wanting me to change passwords and do other things. I'm afraid if I try to go through this while Sanity is running, I may, in the process, break Sanity, so I can't readily go in and do that right at the moment. So you'll have to take it on faith that if you had already done that part of it prior to starting Sanity, then you could go in and watch through the UI as the various provisioning tasks run. Right now it's discovering an SMIS provider on the simulator. It's going to go through and create virtual pools, virtual arrays. It's going to start provisioning some volumes. I think it does some exports. It goes through and then tears a number of them down and exercises a pretty good chunk of the block functionality. So ultimately it'll either report success or failure. And so one of the things when you start submitting a pull request, one of the things that you'll be asked for immediately is, can you give the results of the Sanity tests for again. While that's running, we can move to something else. I think most of you, or actually I don't know the answer to this question. How many of you have accounts on CoprHD control? Are you all just using the public get at the moment, or have you have contributor accounts created to where you can actually log into review.coprhed.org? Is that something that folks have done? Not so much. Okay, so that'll be sort of actually when you start thinking about making contributions, you can clone this repository readily, and this is where you presumably are getting the code from, unless you're still getting it from GitHub. Public, read wide open to the world, but if you want to make contributions, you're going to need to be able to log in here. And the model that we use for contributing code is sort of a branch and merge thing. So the main development branch of CoprHD is always master. There are separate branches for releases. So the last release of Viper was 2.3, so we have a mirror of that over here on the CoprHD side that was created to sync with it. Ultimately, the master branch right now is labeled as version 2.4. Once CoprHD goes toward a 2.4 release, then there'll be a release branch created for it, and the master branch will step up and become 2.5 or whatever the next version number is set. So there's always a master branch is sort of tracking the next major release, and then other releases are over in their own branches. But if you want to actually create a change for something, then you create either a bug fix or a feature branch off of the release you're trying to track. So if you want to make a contribution to 2.4 and 2.4 is currently master, then you create a branch off master and call it feature fix the sanity scripts, or feature, whatever it is you're trying to work on, or bug fix. They can actually be created directly from Jira if you're working them within the Jira system and tell it I want to
Just one comment. I'm not sure if everybody is familiar with the task concept. So just two things. The Git code repository also has very nice UI for doing code review. for some approval from. So, okay, so when you clone your work, so you'll be cloning notes from these types of strokes. You can submit pull requests from your drawing. Just create nice big. The same way you guys use Garrett for OpenStack.
So from the standpoint of an end-to-end flow, right, presumably you'll start in Jira with either a feature or a bug that you're trying to fix. You would assign it to yourself. This is an epic, so not quite a great example, but let's find some of the starters. So we're working on identifying a set of relatively simple bugs that would be a good place to start. So it looks like we've only got 3 that have been so identified at the moment, but in theory this label equals starter is what some folks in the engineering organization are putting as a label on some bugs that are good places to start for making a change. So maybe by the time we finish this meetup we'll have some more identified and you say, okay, I want to see what I learned in the meetup. Do I know how to make a change? So you would start by trying to find a Jira you wanted to work on. You'd find a bug, here's a bug, it's minor, it has some description of what it is. You would assign it to yourself, you would start progress on it, and then you can actually from here say create branch, and it will actually create a bug fix branch in Stash for you to work on your code change. And so you check out your code and you create the branch, and then you make your change in that branch, test it, do all of your development that you need in your branch, and then you push that branch up to review CoprHD org. At that point, everyone can see the code that you've changed, but it's not in the master branch. It can't hurt anything yet. So as soon as you feel like, you could push it as many times as you want. If 2 of you are collaborating on something and you want to share code back and forth, you can push your code up and they can pull it down. In other words, you can do whatever you want in your private branches. There's a naming pattern set in Stash that bug fixes are supposed to be in branches that start with bug fix, and features are supposed to be in branches that start with feature. If you create it through Jira, it'll do that automatically. If you create your branch manually, that's okay too, but you're going to have to follow the naming pattern or it won't work. But regardless, ultimately you push your code up to Stash, but it's still in your private branch. How does that help anything? Ultimately, the step that you're going to have to take when you want to actually have it merged is creating a pull request. And so I'll show you what pull requests look like. They are presumably, well, if you don't have an account on Stash, I'm not sure you can see these yet, but as soon as you get a contributor account, you'll be able to see all of the pending pull requests, and these are all the millions that Tom needs to review. Where are you, Tom? Are you working on that right now? All right, so let's go look at a pull request. This one has actually got some reviewers already have weighed in on it, but basically a pull request has a number of different things. One, it's got a title that explains what it is. This is kind of a bad example at the moment because it has a reference to our old Jira system that was the internal Viper one. All of the new Jiras are COP for CoprHD, so you'll see a little of this as we continue to work through transition. But you basically, the job in a pull request is to describe what the change is, what testing you've done in it. It'll have linkages to the Jira. We have basically a continuous integration system that as soon as you submit a pull request, it's going to try to build the code that's in your pull request, and if it doesn't work, we're going to see it right here in the Jira that the code you submitted doesn't even build. You can be pretty sure that's going to be the end of the review process right there. Submit code that builds, and then we'll take a look at it. We're working on getting the Sonar integration right in here as well, to where the next thing we'll see is, okay, the mainline code currently has X and Y major minor issues in it, and your code has either less or more. That'll be another criteria that we're reviewing on, as well as did it pass sanity? Did you, there's a whole checklist of things that we have on the wiki for things that you're going to want to put in a pull request.
It's actually interesting that these reviews were failed, but it's unaccepted for charges.
That was a curious circumstance for sure. So then, in addition to all that other stuff, you can actually see diffs within the pull request and go in and a conversation can start like, what on earth were you doing here? And so basically a conversation can happen between the reviewers, who can be, any of you could be reviewers, as well as submitters of code. Ultimately, committers are going to have to be involved to get your code merged, so at least a couple of committers are going to have to sign off on code before it'll actually get merged. So we encourage everyone to review code, look at what other people are doing, learn from it, share your knowledge with them as well. And so basically, ultimately, to get code into the main line or in a release branch, you're going to have to get the appropriate number of approves by committers and others, and ultimately someone's going to hit the merge button, and at that point the code's going to come out of this bug fix branch and into master, and that's when it's really part of CoprHD. Until then, it's just a proposed code change that someone has made. And so the whole flow, and then of course once you've merged it, then you go back to JIRA and you mark the issue resolved, and sort of the circle closes itself. But the pull request process is sort of gives you a way to put whatever you want into a private branch without bothering anyone. But then when you say it's ready, that's when you create a pull request and supply all of the information that we have. If you go look under on the wiki, there's this whole section on under technical documents on development standards and contributing to CoprHD and the code flow. And so you're gonna want to go through and read all of this kind of stuff to know sort of the kind of questions that you're going to be asked when you start managing the code check-in process and all that. So there's a lot of detail here, but the basic steps are pick your issue to work on, create your branch, make and test your changes, push it up to the central repository, and then submit a request for review so that the folks on the project can look it over and decide what issues need to be taken care of before it can be merged safely into the code base.
Is it supposed to pick their own reviewers, or is that automatic now?
By default, when a pull request gets created, at the moment it's basically auto-adding all of the committers to it. Ultimately, we may want to, that's what's leading to Tom having 20-something things in his inbox. So we may ultimately want to have a more fine-tuned approach to that, but until, number one, we're not sure how people that are new to the project would know who should review their code, and we figured it was better to have broad visibility than no visibility for review requests. So that whole process is still being worked out as far as how to fine-tune that. So let's take a quick peek back and see.
If you make a pull request and it's not being looked at, you probably keep that, right?
Well, I think particularly for...
I'd be lots to go by, and I'm like, I don't know what that code... I'm not an expert in that area of code, so I don't look at it.
Yeah, I think particularly for contributors that are coming into the project new, it would be a good thing. I mean, if you create your pull request and put it out there, that's great, but it would probably also be good, on your very first one to say, hey, I'm trying this as a CoprHD contributor. If you don't get a response pretty quickly, then, ping Laura, ping one of the folks here whose name you know, and say, hey, this is a thing that seems to be in one of your areas. Can you take a look? Can you make sure I have the right reviewers on it? And that's a conversation we can have also in the developer forum and the rest. Hey, I'm working on this code change. I've submitted it. Who are the right reviewers?
Hopefully, by the time you submit a pull request, you've already been in communication with whichever team works on whichever area your pull request affects. So people should know you're bringing in code. The first time people hear about this code is when they see the pull request. That's going to take a longer time.
Yeah.
I think we should have a celebration for the first.
It really should.
You need a prize.
The first actual submission.
What are you suggesting?
Submitted and...
I don't know.
What are you sponsoring?
We already blew the t-shirt. Something else.
I'm thinking something like a
good.
do that.
Joe's going to stick the typo in the comment somewhere. That's right.
Sometimes it's a really big deal for us to get pull requests in, depending upon the size. You may have
a student, maybe an interview or a hire, I don't know.
you may have to go bug people. Don't do backdoors or something.
What else can we answer questions about, process-wise or otherwise?
Do you want to, so you mentioned those bugs that are sort of
Yep.
started, but I mean,
I'll send the query out, but basically,
but like we want to, so like tomorrow we'll talk about all kinds of new features and other things. Well, not because there's bugs, but like,
No, just
it
for
should
learning.
be one like water through the pipe kind of exercise.
No, just for learning. Right?
Yeah,
It's
maybe it's like
a good thing.
pick one each or something.
Yeah.
And just like
Like 3 little groups of
go through the whole thing, and then these are really starter bugs. Hopefully, it doesn't take like all that long. It's just all the mechanics kind of get worked out. I will send the bottle of champagne to the station.
I will. I got one. When we ship version 1.0.
we have his chat. Look at if you're logged into the Jira system, it's got links to all the various tools that are part of it, including the HipChat, so that's that. We've got links to Jira, GitHub, Dash, anyway, all those wonderful pieces.